Welcome to the Deep Dive. We're here to cut through the noise, get straight to what matters. And today, well, we're diving deep into something pretty insidious. It's silent hardware failures. Specifically, those faulty chips that can be buried deep inside IT networks. These aren't just small problems, they can cause real catastrophes. So our mission today is to pull out the key insights from the material we've looked at. We want to see how smarter asset management, things like 2D barcodes, NFC tags, even AI, how that's becoming a frontline defense.
Exactly. And it's so important to stress these aren't just theoretical worries. The sources make it clear these are real threats.
Yeah.
Tangible. And the consequences. We're talking multi-million-dollar impacts if you don't catch them. Maybe the best way to understand the stakes is to jump into a specific story, a real-world example.
Okay, yeah, let's do that. The material highlighted a really compelling story involving LaSalle Solutions back around 2025. So Picture this. A specific chip buried inside some Cisco gear. It had this hidden flaw. And after about, 18 months or so?
Yeah, around 18 months.
The chip would just fail. It would break the device. Routers, switches, just dead.
Turning into expensive paperweights, basically, overnight.
That's a terrifying thought, isn't it? Your core network gear just stopped.
Absolutely terrifying. And think about the scale across large networks. The potential fallout was just immense. But LaSalle, they had something up their sleeve. Their asset management platform, LAMP, it was both internal and customer-facing. And it turned out to be their secret weapon in this whole situation.
Okay, LMP. So what was it about LAMP? What data did it have that made such a difference here?
Well, the key was that LMP tracked assets right down to the PID level. That's the product identification code.
Ah, okay. Really granular detail.
Exactly. Super granular. So they could instantly pinpoint exactly which assets had that ticking time bomb inside. And crucially, this meant they could tell their customers before anything actually failed.
Proactive notification. That's huge.
It is. And it also helps speed up the whole RMA process, the return material authorizations with Cisco. This got their customers bumped up the priority list in what became this global scramble for replacement hardware. If you remember, Cisco was prioritizing governments, first responders, hospitals, rightly so. But for everyone else, it was basically first come, first serve. So getting in early was critical.
And what's really striking from the material is how much faster LMP was. Faster than other Cisco partners, apparently even faster than Cisco's own internal tracking sometimes.
Yeah, that's what the insights suggest. There was this one story, really telling. A customer had actually been told by Cisco, you're fine, you're clear, none of your gear is affected.
Okay.
But then LaSalle checked their LMP data, and they found a specific serial number, a device sitting right in the heart of that customer's data center, weeks, maybe months away from failing.
Wow. So Cisco's record said clear, but LMP knew better. And just think about the implications there. If that customer had just relied on the manufacturer, their security gear could have just collapsed. You're looking downtime, maybe data exposure, network breaches. A total crisis.
It really highlights the danger of incomplete data. And broadening out from that one story, this isn't some isolated freak event. The financial hit from these kinds of silent failures, it's staggering. The research points to major outages from hardware failure costing anywhere from, say, $100,000 up to $1 million per incident.
Just for one outage.
Just for one.
Right.
Then you look at cyber attacks, maybe stemming from compromised firmware. 29% of businesses face over $1 million in damages there. Counterfeit devices sneaking in that can cost you $10 to over $100, direct and indirect losses. And don't forget compliance, fines for unmanaged assets. $50K to $250K, sometimes more. It adds up fast.
And, the sources mentioned Cisco specifically has dealt with chip integrity issues before, things like ThreatGreat exploiting those trust anchor modules, and vulnerabilities from hard-coded credentials.
Right. These aren't just theoretical vulnerabilities.
And when you multiply those risks across thousands, maybe millions of devices globally.
Yeah, it becomes a massive multi-billion-dollar headache for businesses everywhere.
So, okay, the costs are huge, the risks are real. It makes you wonder, how can other organizations get that LaSalle level of visibility without having to build a massive custom platform like LMP themselves?
Right.
Is there a more accessible way now?
That's exactly where things are heading. The solution discussed in the sources really combines two things: smarter asset tagging and these structured data platforms. Think about solutions like Rainfall Digital is one example mentioned. What they offer is this combination. You get things like 2D barcodes or NFC tags on the equipment, But these aren't just dumb labels. They encode structured metadata, rich data.
Like what sort of data?
Oh, the model number, the serial, crucially, the configuration history, all embedded right there. Plus, they often use digital product passports. These verify authenticity, track the hardware's life cycle state. Is it new? Is it refurbished? Has it been tampered with?
Okay, so you get much richer info right on the device itself.
Exactly. And then all that structured data feeds into cloud-integrated asset databases. Databases that are built so AI can actually scan them, looking for anomalies, cross-referencing with known issues, manufacturer data.
Right, so it's not just about having a list anymore, it's about having intelligent data.
Precisely. The breakthrough isn't just knowing what you have. Most companies think they know that, maybe in a spreadsheet somewhere.
Which is often out of date 5 minutes after they make it.
Exactly. The real insight here is that your network, your infrastructure can start to, well, almost predict its own weak spots.
Moving from being reactive to predictive.
Totally. In predictive defense. Using data points you might not have even realized were important before. So suddenly, every device on your network becomes intelligent, auditable, traceable.
And the gains for organizations. What does that translate to practically?
Speed. Speed to insight. Knowing what you have, where it is, and crucially, if it's vulnerable, almost instantly. And trust. Trust in the data. You're not guessing based on old spreadsheets or patchy vendor records anymore.
Actually, no.
You know. And that enables that proactive defense we talked about. AI flagging potential issues before they blow up.
So how does the AI piece work once you have all these tagged assets feeding data?
Well, it gets pretty sophisticated. The AI can, for instance, detect aging ships linked to those known early failure PIDs we discussed. It does this by correlating, the component's age, its usage patterns, against known failure rates for that specific product ID.
Okay, so it connects the dots.
Right. It can also predict firmware risks by looking at the update history. Has this device missed critical patches? Is it running a version known to be unstable? It can even spot inconsistencies like mismatched serial numbers and model numbers, which might signal a counterfeit or some other problem. The end game is getting alerts to the right teams before a failure cascades through the network.
Can you give us a picture of what that looks like on the ground, like for an IT team?
Sure. Imagine an IT engineer walking through a data center. Maybe they have smart glasses or just their phone. They look at a rack, scan a device, and instantly they get an alert. This specific ASA router, it's affected by that known chip defect. Our analysis predicts it's about 30 days from likely failure. Submit the RMA now.
Wow. That's incredibly powerful. That's not sci-fi. That's practical application.
It's structured data applied practically. It's exactly what LMP proved was possible, just now evolved, and frankly, more accessible. It shows how much defense you can build if you have clear, actionable data.
So it really shifts the focus, doesn't it? The future of IT asset management isn't just about labels and lists. It sounds like it's fundamentally about building resilience right into the infrastructure itself.
That's the core message, I think. And this challenge, it's universal. It doesn't matter if you run Cisco or Juniper or Palo Alto or whoever. No infrastructure is totally immune to these hidden hardware threats. The tech to get ahead of it exists now.
That makes sense. But maybe someone listening, like a business owner, is thinking, okay, this sounds great, but also sounds expensive, complicated. How realistic is this for, say, a medium-sized business that doesn't have a giant IT budget?
That's actually the encouraging part. These smart tagging systems, like the Rainfall Digital example, combined with AI insight engines, they really are the logical next step, and they're making this kind of proactive risk management much more democratic, more accessible. It's not just for the giants who can afford to build custom platforms anymore. Businesses of all sizes can start leveraging this.
So it's bringing that high-level capability within reach.
Exactly. Democratizing it.
Okay, so maybe the final thought to leave everyone with from this deep dive.
Well, I think it comes down to this. The question really isn't if chip-level failures, these silent threats, will happen again. They will. The real question is, will you know about it in time to stop it from becoming a disaster?